Hello everyone, my name is Louis and today I'm going to be going through the paper that I did for Specialist Mathematics last year, the 2024 multiple choice question book for this video, and I got a 49 out of 50 for this paper, and I just wanted to help make this video to support those doing specialist math and want to get that help from me, and I'll be talking through my thought process as we go through as well. So question 1, repeated random samples will be used to calculate a large number of 90% confidence intervals for a population mean mu. Which statement best describes the possible outcomes? Right, so if you imagine a sample of let's just say this is our sample, and then we have like a normal distribution, right? And then we have on each end we make a boundary that can make this middle part 90%, right? And so we're basically having 90% of the bottom area of the entire sample, entire population. 90% will be under this shaded region right here that I have an arrow in red, and so that's basically what a 90% confidence interval is referring to. So the answer would be A. Approximately 90% of the intervals will contain mu. Okay, because it's approximate, because and not exact, because when we do confidence intervals, especially if it's just a random sample and we're repeating those, we're going to get different confidence intervals every time, right? So it's not going to best describe exactly 90% of the population mu, right? It's only going to be approximate. So that's another key thing there, is that confidence intervals are only approximate. And the reason because of that is because we have samples, random samples, so we don't necessarily know how many samples are we using. Like, could it be 5 samples or 1,000? So obviously the higher you get in terms of the number of samples you're using per set of confidence interval, the more accurate you're going to get to that exact 90% of the value of the intervals will contain that mu value. But obviously it's not, it's just a subset of the population. So question 2, given that we have this equation here, determine the value of A, right? So this is involving partial fractions. So if we just take this as a regular fraction, we know that we got to get the denominator to be the same on both fractions. So that means I'm going to have to times by x on the first fraction on the top and bottom, and then keeping my plus there, and then my 3 over x, I need to make that the same denominator as here. So I'm going to do 3, what's left over is x minus 2. That's what I need to multiply on both sides, the top and bottom, and then letting that equal to this on the right hand side. And therefore what we can do now is we can combine the fractions, and then we can just cancel out the denominators because they're now equal. Okay, so essentially I'm just multiplying the denominator on both sides. Then I just simply expand, simplify, trying to get just trying to find A, right? So once I've done this, what I can do is I can equate I have an x, I also have a -6. So that -6 is obviously congruent here. So I've got that part done. But I need my x's sorted out. So what I can do is I can take out this x as a common factor. So this will just be ax plus 3x, but I've just factorized it. Take out the x. Alright, and then this just involves now saying that, well, I have 1x here, so that means that this over here is also going to be equal to 1, right? Because I have x times something, and I have x times something, which is 1 on this side, and I have, since there's an equal sign, I need to make sure that they're equal. So that means that everything in this bracket over here is equal to 1, and therefore therefore a is equal to -2. I'm just minusing 3 on both sides. So the answer is B. Okay, so both question 1 and 2 are correct, A and B respectively. Now here we just have to consider a proof of the proposition as given using mathematical induction. Within the proof of the inductive step, the proposition for n equals k plus 1 could be expressed as very simple. Wherever there's n, just circle it in the proposition and just substitute k plus 1 for n. So I'm just going to write it out just so I can compare with the answer options. So notice how I'm keeping j the same because that is not n, alright? Okay, and it seems here that they've expanded this perfect square, so that's going to be k squared plus 2k plus 1. Knowing that we just square both of these terms in the front and end, and then just adding 2 times these terms as the middle number, so 2k. Right, so immediately I can just cross out c and d because that is not, they have k squared plus 1, which is not, they're missing the plus 2k in the middle. Okay, so it's either a or b. Now I'm comparing what my n equals k plus 1 proposition, what I've wrote down. I can see that B is the A is the correct answer, because as I said, that J does not change because J is its own thing. Alright, it's part of the integers increasing in the sum of, so it is not the limit, which is what n is trying to say, or k plus 1 in this case. We're substituting for that. Okay, a plane contains the point 1, 3, 1 and is normal to the vector I plus j plus 2k. The vector equation for the plane is, so this is in your formula sheet, and we just go to vectors and just note here the vector equation of a plane. It's right there, exact name of it. So that's going to be r dot n, as in dot product, equals a dot n. Right, so immediately I can cancel out c and d again because we have a cross multiplication here, which is not a dot, so that can trick some people up, but we're not technically multiplying the vectors, we're taking the dot product of them. So it's either a or b. Now I remember my formula, r dot n equals a dot n, where n is just the normal. Okay, so I know that the normal is, there's a hidden 1 here and here, so that's going to be a vector of 1, 1, 2. I can immediately say it's b. All right, and my a vector is just the point 1, 3, 1. Okay, so simply there, it's just b. Okay, the augmented matrix shown is produced when a Gaussian elimination technique is used to solve a certain system of equations with 3 variables. we have that matrix here in the middle. Given that row 1 values of the matrix represent x plus 4y plus 2z equals negative 10, the unique solution for y is, right? So what they've done here is they've given us a sort of simplified Gaussian matrix system of equations, and we know that given that this is x, this is y, this is z, we know that from the row 2 that 2y equals 5 as one of our solutions, which means that just dividing 2 on both sides, I'm going to get the answer of D. And just move on there. Question 6. So we have a matrices. So I think this was called dominance matrix, where we have 0 as lost from left to right and 1 as defeated. So I'll let you read that. But based on these results, a dominance matrix N was partially constructed as shown. Alright, and so an easy trick with these dominance matrices is that we always have zeros along the diagonal because we can never win against ourselves. So that's why it's always going to be zeros on the diagonal. So I can immediately cross out D because I know that there's a 1 in the diagonal, and that can't be possible. Q cannot beat Q as itself. Alright, and then we have player P defeating Q and R. Yep, player Q defeated 2 players, player R and S each defeated 1 player. So that's some context there, but to be honest, I don't think we really need to read this part to solve this question. And the reason why is that it can be a bit distracting and confusing, but essentially just think of it logically, right? If we compare Q and P for this value right here in the box, just look at where else P and Q are. So we know that P defeated Q, right? So that's where we always go from left to right. P defeated Q because we have a 1 there, okay? That means that P defeated Q, which means that for Q defeating P, well, no, that's not possible, okay? Because Q lost to P. So that means I have a 0 there. All right, so immediately I'm also crossing out A. So that gives me 50-50 chance of getting this right until I actually solve the problem. Q and R, well, I know that Q defeated 2 players, and since they lost to P and obviously they didn't beat themselves, then that means they have to have won these 2 games, which leaves B as the answer for that. Question 7. A, B, and C are points in a 3-dimensional space. If 2AB, the vector, equals the vector of B to C, then, and we have our multiple choice options. So I'll just quickly draw a X and Y axis here, and then I can see that I'll just pretend I'm making 3 points. So I have A, I have B, I have C. All right, and I know that if I label these A, B, and C, I know that from A to B, right, which is this this vector going from A to B, this A to B vector. If I times that by 2, so that, remember, it comes with, vectors come with both magnitude and direction. So timesing that by 2 will give me B to C, okay? But note that we haven't changed direction at all. We're only timesing the magnitude of these, okay? We're not rotating it or changing the direction at all. So we can see that A and B and C pass through a straight line, which makes it D. Now let's go through the other options. AB is twice the value of BC. Actually, that mixes them up. This is supposed to be there and there, okay? Because if you think about it, we're doubling AB to get to BC. So that means BC is twice the value of AB actually. AB and BC are perpendicular. No, nothing really says that. I mean, if they were perpendicular, the dot product would equal 0 and other reasons, but they're not perpendicular. It's just simply saying we have a scalar value and we're just essentially increasing the length of that. So say AB was like 5 centimeters, then that means B would be 10 centimeters, but it will still be within the same direction. We're not changing direction at all. Okay, so it's not A, it's not B, and only one plane contains A, B, and C. Not necessarily. There's nothing to say that we only have one plane. We could have, you know, like a plane. A plane is really about just like a sort of three-dimensional or like two-dimensional rectangle in a three-dimensional plane. Okay, we can have these planes. Like, planes don't matter in this question at all, really. It's really, this is the best answer, I'd say. Like, it is possible that one plane contains A, B, and C, but if you watch my other videos, multiple choice options that are like only, never, will always, those are usually wrong because there's always exceptions to them usually. But this one, we can definitely say it makes sense, you know. Yeah. Alright, given z equals 2 cis pi on 3, determine z squared. Alright, so this is also in our formula sheet, I believe. Under real and complex numbers, it's de Moivre's theorem, right? So z to the n is equal to r to the n. So that's our I forgot what it's called, but it's the modulus, yeah. And the modulus and cis, and we have n times the angle theta. Okay, so if we look here, we have theta as that angle, and we have r, the modulus, as 2. Then we know that z3 is just going to be 2 to the power of 3 cis 3 times pi over 3, and that's going to equal to 8 as our new modulus, 8 cis, and then we just cancel these out, so that's going to be pi. All right, and then we just expand the cis out, so we have 8 square brackets cos pi plus I sine pi. So you can see what I did there. I have the cis, okay, and I know that cos pi, because of unit circle, pi is just going to be 1/2 circle, and on the x-axis, which is cos, and y-axis is sine, I know that the coordinates are -1, 0. So the cos value is -1, and the sine value, or the y value, is going to be just 0. So 0i, if you want to think about it like that. And then this just cancels out. We don't need 0i, and left with -8, okay, or real value. So the answer is A. All right, so I'll just quickly tick all of these because we are correct and going to get 100% on these multiple choice papers. Question 9. Use a suitable double angle identity to determine the integral of 2 sine squared x dx. Okay, so if we look to our identities, I think I've in the formula sheet, let's have a quick look. It will be under trigonometry from unit 3, year 11. It's assumed knowledge. Double angle identities, we know that there's a 2 sine squared and an angle A, capital A. So if I just rewrite this identity right here, I have cos 2a equals 1 minus 2 sine squared capital A. Alright, just checking I got that right. I know that my capital A value is going to be x. And so what I can do is, because I don't know how to integrate this specific sine squared function, I can just let it equal to something more simpler that I can more easily integrate. So I have that means this cos will be 2 times a, which is, we know that a is x, so that means it'll be 2x, okay? And then essentially what we have now is we have equivalent integrals, so we can just integrate this part now, because it's just the same thing as integrating this. So integrating 1 is just x in terms of dx, and then minus cos 2x. I'm taking this b value and dividing it by 1. 1 divided by that b value, and then changing it to sine. I'm not changing any of the negatives or plus. Not changing it. And then this one in the bracket stays the same. And then I have my plus c. Don't forget that. Alright, so we can see that it's going to be option C. Alright, x minus, just take this sine 2x on the top of the fraction, it's going to be that over 2 plus c. Alright. Question 10. So there are 2 methods to solving this, and I'll show you both methods that I've found myself. So the first method can really just be long division, because we know that z minus I is a factor, and the other factor is neatly z squared plus biz plus 2, and we're trying to find what b is. Okay, so we can just divide this polynomial pz by what this factor will be and try and figure out what this will be, and then equating both our I guess what we have divided by and our quotient, and then equating that to this quotient here, factor. So let's do that. I'll show you how we do long division if you need a refresher. So we just look at the first term here and divide that by the first term of our divisor, so that's z cubed and z, right? So that's going to be, dividing that through will be z squared, and then we just multiplied that by the entire divisor, so we have z squared times z minus I in brackets. We have z cubed minus iz squared, and then we minus that to cancel these out, but we have negative 2iz squared minus, which makes a plus, essentially plus iz squared. So that's going to be negative iz squared remaining, because negative 2 plus 1 is negative 1, and those are in terms of iz squared. And then we look at this first value now, and we divide that by z, so we know that what's left over, our quotient will just be minus iz, because we know that minus iz times z is minus iz squared, because we have 2 z's being multiplied. And then we do the same here when we're minusing. We just minus our multiplication through, so minus iz times, in brackets, z minus I, so we have plus I squared c. Okay, just being really careful with our timesing and subtracting, so these will cancel out because they're the same, and we're just minusing them, and we have z over here, that just goes down, and then minus the I squared z, but I squared we know is just going to be negative 1, okay, because simply we know that I is just the square root of negative 1, so I squared will just be squaring this square root, so we just have negative 1. Okay, so that means we are left with z, if I just clear this up, z minus c. Yeah. And when we subtract those through, this minus z becomes a positive z. We have 2z, and then we just put this down, so we have minus 2i, and then we keep dividing. So the first term 2z divided by z, the first term here of the divisor is just 2, and then we keep multiplying that through to check. We have 2z minus 2i, which is the same thing, so that's going to be 0. So from that, we know that we have a form for the factor when we take out the z minus I here, and that form is z squared plus biz plus 2, and we equate that to what we have found here, which is z squared minus iz plus 2. We know we have the z squareds and our plus 2, so now what's left to find b is just our biz equals negative iz, because we're just canceling out we've already equated basically, and then we know we've equated z because they're common, so bi equals negative I. We also have an I that's common, so we know b equals negative, and it's going to be 1 because there's a hidden 1 there in algebra. So we know that the answer is C. So that was the entire multiple choice paper. If you have any questions, let me know, or any suggestions on what other papers you want to go through. So that gives us 100% on this paper. So well done. Yeah, thank you for watching.